how does the switch know that A reachable via interface? We just discussed that by learning. We'll create a table, we call it the switching table, and that switching table will be learned by each time the packet sent and received. The switch learned which host can be reached through which interface or port. When a frame received with switch learn location of the sender by learning la. So let's say this is sender. The switch the table is empty. So once this one, we know the A interface A had the MAC address A. Okay, this is how learning will happen. So the record link associated with the sending host index switch table using as we can see here, that means the switching interface are limited. So that means each switch can hold a limited number of hosts, cannot be more than that. This is self-learning. So once the bucket is sent, then we are in the table. This is inside the switch. So inside the switch, we have the initial table. We'll find out that A, this one is connected through interface or port number 1. Okay, because we don't have another, we broadcast it or flood it to another, all other board. Okay, when A dash, okay, reply back, then I will know A dash uh, is attached to port number 4. So the next time, selective send, because I know this one is the destination was A, and A I already recorded before, can, and this is what will happen every time I send a bucket. Okay, the switches can be interconnected with each other. So I can interconnect between switch 1 and switch 4. Okay, just technically speaking, okay, the communication between the two nodes with the same at the same layer in the network, normally this one we call it, we connected by type of cable, we call it crossover. I'm not sure if you go through the how to connect the network. Normally we use the UTB, can. So the UTB, they have two type of jamming. The first jamming we call it straight through. That means number 1 go to number 1, number 2 go to number 2, and so on. And the other one we call it crossover. That means if we have we have a sender and receiver, so the communication will become like this. Sorry. So this one we call it crossover. This one you find it in how you connect the color to the RJ45. Okay. The sending from A to G, A here and G is here. This one supposed to go through switch number 4 here and switch number 3. Then Baru come to what? G. We know that each switch is learning. That means the learning table of the switch will be sent to the another switch to find out to combine the house switch table and bucket forwarding in S1, S2, S3. Okay, initial network. Let's say this is our initial network. We have the mail server, we have the router, we have the switch. Okay, I don't know what happened. Why the slide goes crazy? So the router, we know that all switch, they belong to the same network. They are not different network. That means it is just, we call it one hub connection. But once we have a router, then we can differentiate between this is one network and another network. Okay. So the store and forward mechanism, as we can see here, the diagram come to the frame, and the frame is on to do the physical layer and so on. I think we described this one briefly. Okay. Then once we finish from the switches, we go to the PPP. PPP, that means point-to-point protocol. So there is one sender and one receiver. No switch inside, no interconnection inside. No media access control, no need for explicit MAC addressing. So that means just sender send to the receiver. Popular point to point, mostly we use it to interconnect between the, what do you call it? Let's say cities. Let's say I have Alor Star, I have Kangar, I want to interconnect them, I will interconnect them, connect them by point to point link, because it is fast, and we can know most of the time they use fiber optic. This is a design requirement. This one self-study. Please go and read more about the PPP protocol. ESC requirement. So no error. The flow control is quite easy here inside the PPP, because both of them we know each one at the beginning. No need to support multi-point because just one point to point. This is the flag addressing. We have the address control protocol. So as we can see here, data frame. In the PPP, we need to use something we call it stuffing. Byte stuffing, to make sure that if the same sequence of data or bits appears inside the data, we need to stuff some flag. So because we have flag for the beginning and the ending, so what happen if the same sequence of data, we find it inside same sequence of byte, we find it within the data, then here we need to stuff extra one byte after each data. Then the receiver, if received this one and then followed by the same one, it will know that this is just stuffing and need to ignore one. Okay. I told you, so self study this one. This one here, the flag byte. So if the flag byte happen to be inside the data, then we stuff it, we add another one. So once this one receive it, we know this one is just stuffing, and just we ignore the stuffed one and complete the data. Okay. The day in the lifetime, so we need to create a journey down protocol stack complete. So that means the application, transport, network, and link layer. Putting all together, since this is we identify, review, understand protocols at all layers. So involved is in seemingly simple scenario requesting. Just the scenario or the example is just we are going to send a www request. So the student attach a laptop to to the campus network, then request and receive. I want to request what the URL Google. So here this is the school. Firstly, attached to the network. Then we'll send the what request. Open the browser. Okay, and type in the browser google.com. What will happen? We have a web Google server. However, this guy doesn't know the way until now. So what will happen is, once firstly we start by the DHCP dynamic host control protocol. The dynamic host control protocol, this one is the protocol that are responsible of translating the URL into what the URL into IP address, and this one mostly work with something we call DNS server. So the host protocol 2 will send a DNS request with the URL that you type there to the configured DNS server inside your device. So the DHCP request encapsulate the UDP in UDP encapsulation IP as we can see here, and this one goes to the DHCP server. No, the DNS. The DNS will tell us, okay, the Google IP address is like this. Format this acknowledgement contain the client IP address and IP address of the first hop router for it. So this one, the DHCP, reply back to the what host. That means Google can be received at IP address blah 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 blah. So encapsulate the server format of the switch. Then the client now has IP address knows name and address of the DNS server. So the IP address with its first hop router. Then what we'll do, will the request, the IP address of the Google, we find it from the what DNS. The DNS query create encapsulate in UDP. So the DNS, I think, and this is the ARB. Now we need to find the what the MAC address of the what of the server. Then we create the ARB query, and the ARB reply given MAC address of the router interface. Do you have any question? Hello, is it clear? Hello. Okay. So once the DNS server reply, then we know the MAC address of the server and the router. So the next step is start sending the request. So the IBR, the request will go through the IBR become the datagram, and this one of course contains the IP address of the destination Google, switch from client to first hop router. So at the router here, so the switch will do nothing for the IP address, but the DNS router here will do it, will switch between the destination, because the destination, the last destination, we know the IP address of the last destination. Then the IP datagram will go through this one, this area here, you can call it TM. Okay, so the TM here will send the packet to the final network. So this is the network that contain contain Google. The TCP connection start the datagram, the first one, let's say UDP. The TCP will start making a connection between the two. So we call it virtual connection. Then we start sending our data. Once we start the connection, then they start sending our data through the route that we decide just now. Respond with the synchronization. This one to establish the handshaking. This one the TCP connection. Then we start sending out data. The data do the first thing we call it HTTP request. The HTTP request will be sent from your device to Google server. Then the Google server will reply back with with the website content. Web server respond with the reply with the containing page. Then the IP datagram contain a reply routed back to the client. And by this, I think this is the finally, then we can display our web page in the browser. Imagine all that happen when we just write down www something. It is quite quite a number of steps that happen down there, but they are used to happen in no time. So the chapter 5 summary, or what we have today, what we have behind the data layer, like detection of the error and error correction, how we share the channel. So we have the multi-access, the CSMA-CD and CSMA-CA. Then we have the link layer addressing. Then we talk about the ARP protocol. Then we talk about the Ethernet, how the switch and what is PPP. Then we say this one self study. Then we say we show how a day in the life of a web request. Okay, thank you. Assalamu alaikum. Do you have any question? Hello, do you have any question? Yes, I will share the slide and the video. Any other request?